Have you ever wondered why polarized sunglasses remove the glare from a surface? This is due to a physics concept called light polarization.
Light is an electromagnetic wave, meaning it is made up of an oscillating electric field and a perpendicular magnetic field. Light can be unpolarized or polarized. Unpolarized light is light with the electric field oscillating in several directions, such as a light from the sun or a light bulb. On the other hand, polarized light means that the electric field is only oscillating in one direction. For example, if the electric field is only oscillating up and down, this means that the light is vertically polarized. Light that is reflected is polarized parallel to the plane of the surface it is reflected off of.
Light can be polarized using a polarizer. A polarizer consists of parallel aligned chains of molecules. In this example, the wires are aligned horizontally. When a light wave reaches the polarizer, if the electric field is parallel to the wires, it will cause the electrons in the wire to oscillate. The energy from the electric field is converted to kinetic energy, and then to heat. This means that the horizontal components of this electric field will be absorbed and will not pass through the polarizer. On the other hand, if the electric field is perpendicular to the wires, the electrons will be unable to oscillate because of the spaces between the wires. In this case, the electric field is not absorbed and is able to pass through a polarizer. So, a polarizer is polarized in their direction perpendicular to the wires.
The amount of polarization in the reflected beam depends on the angle, varying from no polarization and normal incidence to 100% polarization at an angle known as Brewster's angle. When unpolarized light is incident at this Brewster's angle, the light that is reflected from the surface is therefore perfectly polarized. The size of the Brewster's angle is related to the index of refraction of the two materials on either side of the boundary by the equation tangent theta p equals to n2 over n1, where n1 is the index of refraction of the material in which the beam is traveling, and n2 is that of the medium beyond the reflecting boundary. At this Brewster angle theta p, the reflected light is plane polarized or horizontally polarized to the surface, and the theta p plus theta r, where theta r is the refraction angle, the sum of these two angles are 90 degrees. Light that is reflected from the sun off the surface of a pond is horizontally polarized. This is referred to as polarization by reflection. The sun hitting the water causes glare, making it difficult to see. But by using vertically polarized sunglasses, the horizontal components of electric field are absorbed, removing the glare. This is very useful for fishermen that need to see under the surface of the water, and this is one of the most important applications of the Brewster's angle.
Light can also be circularly and elliptically polarized, which is in between linearly polarized and unpolarized light. To understand circularly polarized light, let's examine this diagram. In this diagram, we're not portraying the magnetic fields to reduce confusion. There are two electromagnetic waves of light, one that is vertically polarized and one that is horizontally polarized. However, when these electromagnetic waves propagate towards your eye, they add together so that it is diagonally polarized, which is still linear polarization. Now let's offset the waves so that the horizontally polarized wave is pi over 2 out of phase. Your eye first sees the light as going up, above the line of propagation, then diagonally upwards to the right, then to the right, then diagonally downwards to the right, then downwards, and so on in a circle because of how the amplitudes line up and add together. Thus, the electromagnetic wave is circularly polarized in a clockwise direction. There is also elliptically polarized light, where the light forms the shape of an ellipse rather than a circle. In elliptically polarized light, the amplitudes of the two waves are not equal.